here we go, guys. So we're going to take a look, more of the same, like I said. We're just adding in kind of the parallel and perpendicular aspect to it. So, keyword, of course, parallel. So first question, take a look at this equation over here on the right-hand side. Which number, easy question for you, which number represents the slope? 2. So I'm going to use that exact same slope. So I'm just going to write down m equals 2, and they want it to go through this point. Now, as always, like I asked you on Friday, is this ordered pair, -1, 1, your y-intercept? No, boo. So we have to use that red formula, point slope form, like we were on Friday. Y minus your y coordinate, your slope, x minus the x. Now, of course, minus the negative, I'm going to make it a plus. We're going to distribute. We're going to do all the stuff. So 2 times x, 2 times 1. And of course, last but not least, let's add 1 over. So my final answer, 2x plus 3. Now, especially those of you that have graphing calculators, if you're on your quiz Wednesday, you're like, oh gosh, I don't know if this is right. Did I use the right slope? I'm worried. Graph both of these equations in your y equals 9. You put them both in at the same time, and you will see when you hit graph, you'll have 2 parallel lines. So you can always quick and easy check it that way. Okay, passing through the point, 1, 2, parallel. So, another question for you. What is the slope of that equation they give you? 3. So we're going to use the exact same slope of 3. And of course, we're going through that point 1, 2. Now again, 1, 2 is not on the y-axis, so I have to use the red formula, point slope form, y minus the y coordinate, x minus the x coordinate. Same deal, distribute, solve for y. I feel like I'm not teaching you anything new today. And let's add the 2 over. Of course, our final answer, 3x minus 1. Same spiel. If you graph both equations in your graphing calculator, hit graph, you'll see you have 2 parallel lines. Okay, we're getting fancy now. Get ready for it. Write an equation line passing through the point 0, 3 that is perpendicular. Okay, so same question, of course. Here's our slope. So, I believe it was Mason that said, to make perpendicular slopes, opposite and inverses. So you have to change 2 things. If this is positive 4/3, I'm going to use negative. And you're going to have to flip this. You're going to have to use the reciprocal. So I'm going to make it 3 over 4. So perpendicular, you have to change the sign and flip your fraction, double flip. Now, I was just about getting ready to do a whole bunch of work. Then I was like, wait a minute. 0, 3, if you graph that, where does it land? Picture it, picture it. 0, 3, where would that land? On which axis? So they just gave you the y-intercept. Winning. So I can just write my answer. I'm going to use my -3, 4 slope and 3 for my y-intercept. Crushed it. Now, if you're like, oh man, I totally didn't recognize that was your y-intercept, if you do your y minus the y, your slope, you will get the same answer. Keep going, you'll get the same thing. And again, if you're ever like, gosh, I'm just not sure this is right, graph both equations and you will see that they meet in right angles on your graphing calculator, because I know a lot of you have your graphing calculators. All right, perpendicular and through 3, 5. Okay. Now, we all can see our slope here in front of x, nothing wild there. So we're going to change it. We're going to change the sign and the reciprocal. So what are you using for your slope? 4/3. Good. I heard it. Positive 4/3. Now, 3, 5 is not your y-intercept. So I do have to use the red formula on the board, our point slope. Y minus the y coordinate. Y minus 5, I meant to write, equals our slope. X minus the x. Oh, good. Some fraction work. Gotta love it on Monday. I don't think it will be too bad, though. Let's distribute 4/3 times x. Here we go. What's 4/3 times 3? 12 over 3, 12/3. But what's 12/3 really? That wasn't so bad for fraction work. We didn't need our calculators. Right?
Yes.
Right? Right? Okay, let's roll that up, of course, 1. Got it. So Does this seem somewhat familiar from last year, your parallel and perpendicular? Some of us maybe we blacked out algebra 1 altogether. Possibly. Okay, you were up. Write the equation line that is perpendicular. It goes through that point. You should be able to do this problem, get ready, in 5 seconds. That's how fast you write. Because you don't need any work. What are you using for the slope? What's perpendicular to a slope of 3? Well, negative 1/3. Now here's why I said no work. What is significant about 0, 4? That's your y-intercept. So I said you could do that one in 5 seconds flat. Maybe less if you write fast. I don't know. Write the equation line parallel. Now this one, yeah, flip it. This one I kind of cringe. Because is 2, 6 your y-intercept? No. Okay, so we got to do the whole y minus the y coordinate. Okay, what are you using for a slope? So we're doing parallel. So do I change the slope or keep it the same?
Keep it the same.
So we're going to use 3. Okay, I'm going to give you a second to finish it. Final answer is y equals, who's got it? Y equals
3x.
3x. We're lively today, crew. Any questions on that guy? Okay, so that's, I mean, it doesn't get any more exciting with parallel and perpendicular. We just need to talk about when you have your special types of lines, horizontal and vertical. So before we read it and get crazy, what type of, you got a 50-50 here, what type of special line is y equals 8? Horizontal or vertical? Horizontal. Okay, parallel. What type of line is parallel to a horizontal? Another horizontal. So I know my answer is going to be the same style. Now, it has to go through this point, 5 comma 6, so y better equal what?
6.
Done. So these aren't going to take us any work, but we have to make sure is it y equals or x equals in which point we're going to use. So you're going to be conscientious. Let's start with our equation here. Horizontal or vertical? Vertical. And we want to make it parallel. So what type of line is parallel to a vertical? Another vertical. We have to go through the point negative 3, 4. So x better equal negative 3. Done. No work necessary. But obviously you have to make sure x versus y, all that good sort of good stuff. Okay, some more. I'm not going to use yellow. It doesn't show up very well. You already told me in the first one this was horizontal, but now you're going perpendicular. So what type of line is perpendicular to a horizontal? A vertical. So it's going to be x equals, and clearly x better equal 5. Okay. Let's do this last guy here. So x equals is our vertical. What type of line is perpendicular to a vertical? Horizontal. Y better equal what? 4 for the y coordinate. So to me these are easy because they don't take any work, but they're tricky. You have to be super conscientious whether you're using horizontal or verticals. All right, home stretch. Write the equation line that passes through those 2 points. Okay, all right. We have the skills to do this. We just haven't put them all together yet. First question. Do you know the y-intercept? Yeah. So we've got that. What are we missing? Slope. We don't have the slope. But of course, one of our formulas on our board helps us calculate slope. Which formula? Blue, green, or red?
Blue.
Blue. So I'm just going to use my y2 minus y1 over x2 minus x1. y2 minus y1, x2 minus x1. So I'm going to have 9 over negative 4, which doesn't reduce, which is okay. I am, though, we usually never keep a negative, one of those kind of unwritten algebra rules. I never keep a negative in the bottom of a fraction. I'm going to kick it out front. And you have the y-intercept, so you are ready to write your answer. So a little bit of work. So like I said, we haven't specifically done this style of problem, but you've got the skills. You know how to do the slope. We've done it. Okay, so look at this guy. Write the equation line that passes through this. I'm like, oh man, you don't have the slope. Are either of those points the y-intercept? We gotta do it all. Okay, let's start with the slope. So y2 minus y1, x2 minus x1. So negative 3 over negative 4. And of course, two negatives, positive. Now, we said neither of those points were the y-intercept. So, we're going to use our red formula. Does it matter, though, which point I use? No. I might use the first one. Jordan might use the second one. We all end up with the same final answer. I'm going to use the first one because I don't know, I feel like it. Y minus the y coordinate, our slope, x minus the x. I'm going to distribute the 3/4. Ooh, we got some fractions again. Love it. Just FYI, there are some fractions on your homework today, too. You're welcome. But you can use your calculator. Okay, here we go. What's 3/4 times 2? 6 over, I see you guys saying 6 over 4, which it is, but let's reduce it. What's 6 over 4 reduce? 3 over 2. Got it. Let's add 4. Now, we can still, I know this seems scary, do this fraction work in our heads. Because negative 3 over 2 is the same thing as negative 1.5. If you like it mixed number style. So, okay, first easy question. What's 4 minus 1? 3. Take another half off. What's 3 minus a half? 2.5. Who needs a calculator? Not us. I mean, you can use your calculator clearly on your homework and the quiz, but we should be able to do some simple fractions in our heads, yes? Now, one last thing. Hang on, Jordan. One last thing. I don't care on your quiz either if you put that as 2.5, 2.5, 5 over 2, whatever equivalent form. It doesn't matter to me. Jordan.
That was my question.
Okay, all right. I don't care. I just like to do the fractions in my head because that's how I roll. Okay,